All right. Welcome to one more session of your WC students. Yes. What is it? We are back with the second revision series. All right. You all know, students, I've already started the final term revision for your board examination. Final revision series I have already started. In that final revision series, I have already completed series 1. Today we are going to start with series 2. What is it? In this particular series, I'm going to discuss the most important physical chemistry numericals. I'll be giving you tricks, how to do, how to solve. I'll be giving you within less time how to completely give the answer. I'll also be teaching you about the marking scheme where the examiner is going to give you everything in this video. So stay tuned. Let us start with our revision. That's most important questions for your term 2. So all the best grade 12 students. Nothing to worry. Always remember, believe in yourself. Yes, students, if you believe in yourself, what happens? Miracles will happen. Yes, I always do. What I do, I stand in front of the mirror and I say, believe in yourself. Okay, believe in yourself. Believe yourself or believe in yourself. So what is going to happen? There'll be a big, huge smile when you believe yourself. Remember that. Okay. Chalo, let us start off. We are going to start again reminding this revision series will include from revision series 1 to 7. I'll be sending completely all the term 2 chapters. Yes, all the term 2 very important chapters we have going to do. Yes, let's start with the session. Right. So before that, please subscribe to the channel. Please like the video and share the video. It is for free, no students. So because sharing doesn't cost anything, and I request you all to send the comments also. Yes, comments and compliments both are accepted. But important thing, share the video to all your friends, because the students who can't afford education, if you share, they can also learn from this video. Yes, let's start with the video without wasting time. All the best. Very important numericals of your physical chemistry. So when I read the first question, this is a very famous question, students. See here. They have asked me, they've given a particular numerical. Let us read it and understand carefully. So nitrogen pentoxide decomposes according to this equation. Okay, done. They have given decomposition of nitrogen pentoxide. The first order reaction was allowed to proceed at 40 degrees and the given below data was collected. Okay, so because there's only one reactor, it's a first order reaction and the below data is collected, the initial rate or the initial concentration of the reactant and the time taken for decomposition. So what are we supposed to do? We are supposed to calculate or check what questions. Okay, first important thing, as you see, the time interval between all the particular concentration terms when it is decomposing is 20 minutes. The time interval is dependent. Okay, perfectly, it is systematically increasing, or 20 minutes interval is maintained. I'll tell you why. What is the thing? Understand. Now the question given to us is calculate the rate constant. Okay, include the units with your answer. Second question, what will be the concentration of N2O5 after 100 minutes? Done. And calculate the initial rate of the reaction. This is what they have given to me. Easy question. Let's start. What clues do I have? I have a clue that it says the reaction is first order. Okay, first order reaction because only one reactant is participating. So I'm going to write first order reaction means perfect. I'm going to learn or first write the formula for first order reaction. Let us note the data which is given to us. What data is given? Okay, let us note the given data for this. So they said calculate the rate constant. I have to find rate constant. Okay, I have to find K from here. Okay, and units also I have to write for this. Okay, done, noted. Let us start. So first important thing, when I see the table here, check here students, when I see the table, the initial rate of the reaction what was there is A naught value, this one, initial. Later on, because the time interval is even, it is equal, so I'm considering I can take up anything, right? So I'm going to start with the first T is equal to 20 minutes and corresponding value, I'm going to take this as A value. Concentration is A. Done. So time is this, concentration is this, final concentration A. and initial concentration is A naught. Now let's come back, write the formula according to the data. For first order reaction, what is the formula for the calculating the rate constant? K is equal to 2.303 by T log concentration of A naught by concentration of A. This is the thing, correct? So how much is A naught given? We very well know A value we have written. Now substitute the values, substitute the values. Okay, done. I'll substitute the values and check. So K value I have to find out is equal to what minutes we are taking? 20 minutes, because the time interval is same. So you can take 20 is the difference. Log of concentration of A was how much? 0.400. How much was A value? It is nothing but 0.289. This is the values in concentration brackets. So what will I do? I will further write it or shift the decimal and make it more simpler. What did I do? I'm going to take the same value like this. Instead of 0.4, can I write it as 4.0? Because it is easy for me to find log. Here also instead of 0.2, I'm making it as 2.89. It is easy. There is a formula now. You know, no students, what is it? Log A by B is equal to log A minus log B according to the formula. So can I apply that in this equation? Yes, I can apply. So what do? I'm going to take that value, K is equal to 2.303 by 20. Okay, so log 4.00 minus log 2.80. Done. Easy. Yes. So normally we very well know log tables are not provided. In the exam. So how should I remember, students? So for this, students, I did one not provided in exam. For this, I did one video how to find log without log table. Please check the playlist. Students. In that playlist, there is one particular series where you can find log. You can also find anti-log without log table. No table required. You can find it. So please check the playlist for this. I have already done. Now, so log 4 and log 2.8. Go through that table and check the playlist. Now, after this, as I already know the value is 2.303, log 4 is nothing but 0.6021. Log 2.8 is around 0.4609. Done. Now I'm going to subtract both. I'm going to find the K value. So 2.303 by 20. When I subtract, how much will it come? 0.6 and 0.4. It will be around 0.412. Correct? 0.1. Yes. Done. So now easy. Further I simplify, further I calculate, I'm going to get an answer of around K is equal to around 1.625. You divide 6259 into 10 raised power of minus 2. Now this is which order? This is first order reaction. So the units would be minute inverse. So the rate constant value I have got, the first answer is over. So I'm going back to the video and I'm writing here units also have written. I got an answer of K is equal to 1.6259 into 10 raised power of minus 2 minute inverse. Over. Done. Now what should I do? What will be the concentration of N2O5 after 100 minutes, they asked. No problem. Go back to that reaction. Now I'm going to calculate. Sorry, let me put my writing pad properly. I'm going to calculate the second part. Now what did they say? They are asking me when time is equal to 100 minutes, how much is what? They are asking what would be concentration of A? How much? So, according to me, initial concentration is always the same. How much is it? 0.400 mole inverse. Rate constant value, already you have calculated 1.6 into 26 into 10 raised power of minus 2 minute inverse. Done. Now substitute, write the rate law. So, what is it? First of all, for the first order reaction, we very well know K is equal to 2.303 by T log A naught concentration by A. This is what I have to find out. I have to find this. Now cross multiply this. Yes, what will you get? Simple. Yeah, easy. Like you can, if you don't cross multiply, so it's okay. You can finish like this only, but later on you need to do. So how much is k, students? How much is k? K value is 1.626 into 10 raised power of minus 2 is equal to 2.303 divided by t is how much? T is how much? Basically 100 minutes, 100 minutes log a naught. A naught is 0.4. Yes, log A. I don't know log A. This is log A. Done, students. Easy. So now easy to find out. So what you do, you first simplify this part. Simplify this part means you are going to cross multiply these two. Cross multiply these two directly and simplify. So first thing 1.26 into 10 raised power of minus 2 into 100 divided by 2.303. Easy. Make it equal to log 0.4 by A. Easy, students. Just simple. So you should find out A now. Put the concentration of A here. So find out A. This simple. Take out A. Now what you can do is you can solve the question here only. First solve this part. This part you solve. So when I solve that part, I already did. I'll be getting an answer of 5.082 is equal to 0.4 by concentration of A. What is A? Cross multiply. A is equal to 0.4 divided by 5.82. How much is it? It'll come around 0.4 and it'll come around with 0.0787. Almost this is the value of that. They asked me after t is equal to 100 minutes, how much is the value? So I will go back to that particular thing. And second answer, after 100 minutes, how much did I get? After 100 minutes, A value, I got it as 0.07N8 molar. Because it is concentration, I got so much. What did they ask? The last question is, calculate the initial rate of the reaction. Come back to the question. This is step 1. This is the first part. This is the second part. Now we are going to go to the third part. Is there any place? Yes, third part there is a place. Now third part, what did they ask me? They're asking me to calculate initial rate. How much is the initial rate they're asking? Okay. Now simple. We very well know initial rate is nothing but rate of reaction. Rate of reaction when the rate of the reaction T is equal to 0. Correct. Now see, when T is equal to 0.00 minutes, how much was A? A value, that is your, this one, was 0.400 mole liter inverse. Right? How much was your K value? K value was, I got 1.26 into 10 raised power of minus 2 minute inverse. Done. Now, you are going to write, just write, students, you have to calculate initial rate. Initial rate is equal to K into A, done, which is equal to, this is initial rate, 1.626 into 10 raised power of minus 2, write the units, important, into concentration of A is 0.400 mole liter inverse. So when I multiply everything, I'll be getting an answer of 6.04 into 10 raised power of minus 3. Because it is first order rate law, the units are mole, liter inverse, minute inverse. Done. So this is the value. Sorry, I should not write. Basically, it is not K, it is initial rate. So the initial rate, what they are asking is so much. So because it is your first order reaction, I have written the values. Simple. So they've asked me 3 points. They asked me to calculate the rate constant. I did. I calculated. They asked me to also calculate how much would be the concentration of A at 100 minutes. I did. They asked me to calculate initial rate. That also I did. So very important question. Check this. Then next question. For a reaction, ammonia in the presence of, okay, there is ammonia itself, gaseous reactant. In the presence of a metal catalyst, it is forming two different gases, nitrogen and hydrogen. So they said rate is equal to K. Oh, rate is dependent upon only rate constant. That means it is not dependent upon any concentration terms. Oh, I understood the question. Now, rate is dependent upon only rate constant. Done. Now they're asking, write the order and molecularity of this reaction. Easy. Now tell me students, when I say rate solution, we very well know when rate is dependent upon rate constant, not any concentration terms, then what do I say? Concentration terms, the order of the reaction is zero order reaction. Correct now? Zero order reaction. Simple as that. Yes, because what happens? All are gaseous reactants. So in the presence of catalyst, what will happen when you are applying high pressure on this? All the gases, whatever are there, they get saturated. Gaseous state, diffusion would be more. So at high pressures, all the gases will get saturated, and further you're trying to change the conditions, nothing. You can't, whatever condition you change, the rate will not depend upon the concentration of the reactants. So two molecules of ammonia are reacting, correct na? So that's why, remember students, when it is gaseous, remember they will get saturated in the surface. When you heat it, they'll get saturated at what? At high pressures. High pressures they get saturated, that's why you will not have any gaseous molecules present. So order is zero. Now tell me the molecularity. Molecularity is nothing but number of molecules participating. How many are participating here? Two molecules of ammonia are participating now? Yes. Now tell me the third thing, what are the units of K? Rate constant, okay. For zero order reaction, the rate constant value is mole liter inverse second inverse. Removed. Easy? Chal. Easy, students? Check carefully. So for gaseous at high pressures, gases get saturated. So the rate of the reaction does not depend upon the rate concentration of the reactants. Next question. This is empty. So check carefully. Remember, as you have gaseous reactants, what will happen? Reactants, what will happen? Important thing, on metal surface, whatever are there, if the gaseous reactant, when you apply high pressure on this, so at high pressure, automatically the gases get saturated. Gases get saturated. When they get saturated, the rate of the reaction, what does it depend upon? The rate depends upon, the rate depends upon only concentration, the rate constant, not on concentration terms. Done? Next question. What do you understand by the rate law and the rate constant? Okay. Identify the order of the reaction if the units of its rate constant are like this. They're asking you to identify the rate of the reaction. Just see. Remember students, you have three things. Zero order reaction is 1. Make a line. First order reaction is 1. Make a line. Second order reaction is 1. Make a line. Okay, done. Now, let me make a line here. Remember the units. For zero order, it is mole. Okay, remember. Liter inverse, second inverse. For first order, it is only second inverse, time inverse. For second order, it is nothing but liter mole inverse, second inverse. Remember. That means for zero order, it is always ms inverse 1. For first order, it is second inverse 1, molar second inverse. Third order, it is nothing but your m inverse second inverse 1. That's all. Remember the question. Easy? Sure. So what is this now? For this particular thing, if we see, where is L inverse, mole inverse, where is it? Okay, L inverse is here. Mole second inverse. So is it not your first order reaction? It is first order reaction. Okay. Second thing, okay, L is nothing but positive sign, mole is negative sign, which is this second order reaction. Second order reaction. Okay, easy. Let us see one more question. So there's one more important question. Check. For a chemical reaction, R is giving me, or R is leading to products. Done. The variation in the concentration, okay, concentration versus time graph, the plot is given. There's a plot given. Now predict the order of the reaction. What is the slope of the curve? Now check students what is happening. Observe. When time is equal to 0, how much was the concentration of the reactant? It is maximum. Done. Done. Now observe carefully. When time has increased, let us make it as 20 minutes, 15 minutes or something. Slowly the concentration also is decreasing. Now concentration also is decreasing. Now what is the understanding? Careful. The rate of the reaction, zero maximum, with time it is decreasing. Is it dependent, students? Is it dependent? Rate of the reaction is dependent on the concentration? No. Since rate of the reaction is not dependent upon the concentration, the reaction is zero order. Reaction is zero order. Yes, the reaction here, rate is dependent upon K, not on concentration terms. R and T are the graph. Now, according to zero order reaction, what is the slope given? Remember, normally slope is you're getting a negative graph. Is it not a minus K slope? Is it not a negative slope? Yes. The slope, whatever you're getting, is a negative slope, which is equal to dr by dt. Easy, easy. So the zero order reaction, you'll be getting a negative slope. Remember that, because you'll be the rate of the reaction does not depend upon the concentration terms. Second, next question. For a chemical reaction, reaction gives products. The variation in the concentration ln R versus time plot is given. Okay. Predict the order of the reaction. What is the slope of the reaction? What are the units of rate constant for this reaction? Easy. First of all, remember students, here you are trying to get an intercept. Correct? Na? You're trying to get an intercept here, this part, when you extrapolate this. Yes. So, careful. Remember, here, the rate of the reaction. Okay. So, what did they ask me to find out? First, predict the order of the reaction. Okay. And rate constant, they asked me to find out. Okay, done. Then they asked me to find out slope of the curve. Okay. Units of rate constant are easy. So basically, when you in the graph, when you get an intercept sort of thing, remember the order of the reaction here is first order reaction. First order reaction. Okay, right. So for the first order reaction, they asked me to find slope. I have to find the slope. So remember, slope wise, how should I find? So slope for first order reaction, how can I get? Check, let us see. Now you write the reaction order first. They said ln R, na? Check. ln R is equal to minus kT plus R ln R naught. This is what we have derived for the first order reaction, right? So now you're comparing this equation with y is equal to mx plus c, right? Right. Now check students. Here, this is on the y-axis. As we have seen in the graph, earlier graph, it is like this, ln R in the y-axis. Okay. Then on the x-axis, you have time. Done. Yes. Now, m is negative slope. You are getting a negative slope. Minus k is a negative slope. And the intercept, whatever you're going to draw, this is nothing but ln R naught. See this, ln R. This is your intercept. So, according to the question, what did they ask me? The B part they asked me is, what is the slope of O? Slope of the curve, whatever I'm getting here, the slope of the curve is what, students? It is nothing but minus k. Remember that. Minus k is the slope of the curve, and the intercept what I am getting, whatever I am getting is nothing but ln R naught. Done. Easy. What was the third question? Okay, let us read. So I got here first order reaction. Done. Then I got what is the slope? Minus k. What are the units of rate constant they asked me? Okay, let us find out that. So units, third part, I'm finding units of rate constant. Hmm. So normally, just these students, first order reaction, what is the formula? What is the formula? It is nothing but rate of the reaction, right? Or in terms of your like formula or rate constant 2.303 formula, which we have written earlier in the first question. So remember, whenever you're learning a formula, try to learn perfectly the thing. Okay. So basically, the rate constant of a reaction or rate constant of the reaction is equal to 2.303 by T log of A naught by A. Correct now? This is your rate constant first order reaction. They are asking me to find out the units of this. So 2.303, okay, that's constant, right? So can I make this concentration term or time term in? So K, I'm getting this outside. So concentration term is mole liter inverse. Okay. T value is second log. So basically, I'm just taking this, I'm cross multiplying this one, students. I'm just cross multiplying. A value is mole liter inverse. Second log A naught value is nothing but, can I do like this? This one also I can cross multiply. Okay, we'll do one thing. What I'll do is, instead of this part, I'll just show you step by step. Check here. First thing, I'm taking this concentration as mole liter inverse. Take the same thing. Then second, okay, into 1 by mole liter inverse. Done. Yes, taken one time is equal to second inverse. Easy, correct now? Yes, this mole liter in gets, second is in the denominator, so the unit for rate constant is second inverse. Done, students, got it? So I took out first thing, cross multiplied A by T, and this becomes reverse 1 by mole inverse. So I got for first order reaction, the units for the rate constant are second inverse. I got three answers for this reaction. Easy. So I'm summarizing before I go to the next question. Remember, students, in the exam paper, they are going to ask you questions like, check carefully, order of the reaction, molecularity of the reaction, rate constant value, rate constant units. Okay? Sure. Done. Next question. Oh, check here. For the hydrolysis of methyl acetate in aqueous solution, the following results were obtained. Okay, done. They have given it is hydrolysis of methyl acetate, means hydrolysis is nothing, just they've given one component, methyl acetate, so it's first order reaction, it depends upon one. Right, now they've given the data for time and concentration of A. Now what are they asking? Show that it follows pseudo first order reaction as the concentration of the water remains constant. Okay, done. Now they are asking, calculate average rate of the reaction between time interval 30 and 60. Okay, log value 2 is given, log 4 is given. Let's start. So what did they say? Show that it follows pseudo first order reaction, okay, and the concentration of the water is kept constant, means it is pseudo first order. Okay, done. Both two reactants are participating. One is methyl acetate is one component which is participating, and water also is participating. But because this is taken in excess, you are saying this as pseudo first order reaction. Correct? You are saying this is pseudo first order reaction. Okay, done. Accepted. Let's take this. First thing, I'm going to write, because there is one reactant term, that is methyl acetate. So I'm writing first order reaction for this. What is the formula? K is equal to 2.303 by T log A naught value by A value. Okay, done. Now, what did they say? They said, check, calculate the average, they said show that it follows pseudo first order reaction as a concentration is given. Okay. Now, if I see, this is the initial time, this is the next time interval, this is the next time interval. So the time interval is standard. So when the time interval is standard, you're saying exponentially it is increasing, means it is increasing, means first order reaction. So what am I considering? I'm considering t is equal to 30 seconds because the time difference is 30, correct? So substitute k is equal to 2.303 by 30. How much is the log value here? Log value at 30 it was 30, it was 0.3, at 0 it was 0.6. So write down. How much was initial? Initial was 0.6. How much is final? 0.30. Done, students. Easy. Now check. So this is it, your 30 seconds. Now can I solve this? 30 and 60. Right. They've given the values already. 30 value, log 2 value they've given, log is okay. Log we don't know, but anyways we can cancel this now. 3 ones are 3 twos are correct. This goes here 0.3 and 0.2. So finally when I simplify I get 2.303 check divided by 30 into 0.3010. Correct, students? Yes, 3 ones are 3 twos are you take and log 2 you make. Log 2 is 3.3010. 0.2 you get that. So it is 0.3010. So now further simplify, I'll be getting an answer of so much, which is the rate constant value. Okay, now let us find out for T60 also same thing. Yes, T60, T60, T is equal to 60 seconds. Now check, K is equal to 2.303 divided by 60. Log value, how much is initial? 0.6. How much is the value at 60 seconds? 0.15. So further I 0.15 and 0.6 when I do, and I simplify and take the log, I'll be getting a value divided, which is nothing but just like this, which I did here. Nah? I took out the log value. Like that, I'm getting a value of 0.602. So when I further simplify, I'll be getting an answer of 0.0231 second. This is at your 60 seconds value, where 30 seconds you're getting 0.02 and 60 seconds also you're getting 0.02. Both see here. Because the time gap is only 30 seconds is the time gap. Time interval is 30 seconds, which is fixed. That's why the rate constant value also, both the times you're getting same rate constant value. Done. Now what did they ask? Okay, before I go, one more question is there. We'll do that. They asked me to calculate something called average rate of the reaction. See the question? They asked me calculate average rate of the reaction at 30 seconds and 60 seconds. Shall we do that? Sure, let us do that. 30 seconds and 60. So average rate formula is what? Average rate is equal to C2 minus C1 by T2 minus T1. Correct? How much is C2? How much is C2? So basically concentration is decreasing. Correct? So how much is C2 value, students? Let us see. Go back. Let us go back. C2 value is 0.15 and 0.30. Okay. Done. So C2 value is 0.15 minus 0.3 divided by time was how much? 60 minus 30, which comes to 0.5 and point. This one is okay. 1.15 divided by 60 minus 30 is 30, and answer is around 5 into 10 raised to the minus 3. You'll get units are mole liter inverse second inverse. So the average rate of the reaction is so much. So done, students. So they're asking me. See the question. We read this. So I explain this question saying the water is taken as excess. So we neglect this and we get an answer. That is first one. Then I calculated 30 to 60. So what did I get? When t is equal to 30 seconds, I got rate constant value as 0.0231 second inverse. When t is equal to 60 seconds, what did I get? I got the rate constant value again as 0.031 second inverse. So it says it is constant. Constant. Average rate also they asked me to calculate. Average rate, how much did I get, students? Average rate using C2 minus C1, I got 5 into 10 raised to the minus 3 mole liter inverse second inverse. That's it. The question is easy, directly done. Correct, my students? Sure. Let us go into the next question. Okay. As first order reaction takes 20 minutes for 25% completion, decomposition, calculate the time when 75% of the reaction will be completed. Oh, so it's a first order reaction, it seems. For completion of 25% decomposition, it's taking 20 minutes. So they're asking calculate how much would be the reaction when 75% of the reaction has to be complete. Okay. So they have given me one question and log values are given. They've given me a clue. They said it is first order. Okay. So what should I find? Let us write. A, let me consider the basic initial concentration as 100%. Okay. Done. Second important thing, they said A 100 minus 25. So 75% is the thing which I have to calculate. So 25 is completed, 75 is left out. So write the rate constant value, that is the rate, that is equal to 2.303 by T log of A naught value by A. Now what should I find out? I have to find out how much is the rate of the reaction, how much is the reaction part, whatever, like first order reaction, 25% to complete, 20 minutes it took. So I have to find out what time will it take when I have to complete 75%. So let's find out. So K value I'm substituting 2.303 done by 20, rather 20. Why did I take 20? Basically 20 minutes they have given. So nothing but log 100 by 75. So the first one I'm calculating and doing it. So first of all, when I further calculate this question, first divide this 100 by 75 or log A minus log B, find out. This is log 100 minus log 75. When you calculate that, what do you get? You get an answer of 1 by 20 into 2.303 log 1.33. Okay, so log A minus log B, do that, you get this value. So further simplifying, when I multiply and find out log 1.33, find out in your, I told you, I did a playlist where finding log without log table, you get 0.1248. So when I solve this, I get an answer of 0.143 minute inverse. Done. So they asked me to ask for 75%. So 75%, how much will it take? So I'll write now. So for 75% completion of reaction, so how much will I take? How much? So write the formula again. Normal formula is K is equal to 1 by T into 2.303 log of A naught minus A is a formula. Now what should I find out? I have to find this. Cross multiply. T is equal to 1 by K into 2.303 log of A naught value by A. Done, students? Yes. So this rate constant value, how much did I get? How much did I get? 0.143. Substitute that. Is equal to 0.43 into 2.303 log 100 by 25. 100 by 25, because they've asked me to complete 25% now. Yes, 25. So when I solve this, I'll be getting an answer. So find log 100 by log 25. It's nothing but log A minus log B. So log A by B is equal to log A minus log B. Do that. So when I solve the question, I'll be getting an answer of almost 96.96 minutes. So there, it means for 25% completion, 96.96 minutes are required. Easy, students? That is how I did it. Now let us see one more question. Given the graph drawn, okay. So analyze the graph drawn between concentration of reactant versus time. Done. So here what are you observing? Observe carefully, students. As the time is increasing, the time interval is same. See, initially when time was 0, the concentration was maximum. As the time passes, the concentration is decreasing. Tell me, that means the rate of the reaction is dependent upon one of the concentration terms. Correct? One concentration. That's why That's why they asked me predict the order. Yes, the order of the reaction here is first order. First order. And theoretically, can the concentration of the reactant reduce to zero at infinite time? Yes. Now tell me, can I at infinite, taking the reaction at infinite time, and can you make the concentration of the reactant zero? No, not possible. Why, students? Already when you see here, when you see the curve never touches the x-axis. See this. Never, it will never touch. It is exponentially going, I mean, like this. It means it is decreasing like this. It will go parallel. Can it touch the x-axis? Yes. Never it can touch. It is not possible. So remember, you can't. You can't make, because due to exponential relationship. Exponential relationship, and it never touches the x-axis, and it or the curve never touches x-axis, never touches x-axis. That's why I can't take it. Easy. Next question, let us see one. Oh, big question. Nitrogen peroxide decomposes according to the reaction. This one, that they have given this data. The first order reaction was allowed to proceed at 40 degrees, and the following data is given. T value time is given. The difference between all is 20 minutes only. So the concentration, see here, with time the concentration of N2O5 is decreasing. What did they ask me? They asked me, calculate the rate constant of the reaction, include units with your answer. Question number 1. Second, calculate half initial rate of the reaction. Done. Question number 3. After how many minutes will N2O5 be equal to 0.350? Okay, done. Let's start. First question, calculate the rate constant of the reaction and units. Let's start. First thing, remember, let us note first, when t is equal to 20 minutes, how much was the rate constant value when t is equal to 20 minutes? This one is your A value, correct? Or this is your A naught value, correct? Done. So I'm noting it. So check. When t is equal to 20 minutes, A value was 0.289 mole liter inverse. How much was A naught value? It is 0.400 mole liter inverse. The first order reaction they said. So for the first order reaction, check carefully. K is equal to 2.303 by T log R naught by R. What did they ask me? They asked me to calculate rate constant. So K I have to find out. So how much is the time? 20 minutes. Log. How much is R naught value? 0.400. What is R value? It is 0.289. So can I make this further simplified? 0.4, reducing the decimal. So I am making this as 0.320 log. I am making this as 4.00. I am making this as 2.89. Same, almost similar sum. Next, let's further come. You very well know, since log A by B is equal to log A minus log B. Correct. So with this, can I further substitute, make it, simplify it? K is equal to 2.303 by 20 log 4.00 minus 2.8. Done, students. So they have given, shall we see whether in the sum they have given the values or not? Check. Log values not given. No problem. I already did a video to find how to find log without log table. So without log table, please check that video. Find log without table. Okay, check that. So when I do this, I'll be getting 2.303 by 20 log. How much is this answer? 602 minus log 2.89 is 0.4609. Done, students. So when further I solve this, I'll be, I think, simplifying this further. 0.6 minus 0.4. Okay, I'll be getting an answer of 0.142. Done. So when I'm trying to further simplify this and understand in the exam, I'll be getting a K value of 1.626 into 10 raised to the power of minus 2 minute inverse. Minute inverse. Okay, got it? Chalo. This is what I got the solved answer. Now, what did they ask me? Rate constant they asked me. So, the rate constant value, I got it as 1.626 into 10 raised to the power of minus 2, and the unit is minute inverse. Then they asked me to calculate initial rate of the reaction. Okay, let us go with that. They asked me to calculate initial rate. So what is the formula, students? Initial rate if I want to calculate. So initial rate, B part they've asked me. So again, write the formula. T is equal to 2.303 by K log R naught by R. Done. How much is R naught here? R naught value is its concentration. It is 0.400 mole liter inverse. You have to write the units. R value I have to find out. T value is 100 minutes. Rate constant value is 1.626 into 10 raised to the power of minus 2 minute inverse. Done. Substitute the values. What should I find? I have to find R. So I'm taking that value and substituting it. So can I write in this formula? Sure, let's write. First we have written this formula. T is equal to 2.303 by K log R naught by R. What should I find out? I have to find this. Substitute. T was how much? 100. Right? 100 minutes. Correct, Anina? They have asked me to find the thing with, because how much they asked? They asked how many minutes will N2O5 take to become equal to 0.325. That is what they asked. So initial rate also they have asked me, what is the initial rate of the reaction? Okay, done. So here basically what am I doing? 100 minutes slot, which I took. How much is the rate constant value? Log. How much was the initial concentration which we took? 0.4 divided by. So first you try to simplify this part. That is easy. Actually, cross multiply both of them. 100 into 1.626 into 10 raised to the power of minus 2 divided by 2.303 is equal to log 0.4 by R. Try to make like this. So further I simplify this. I'm getting an answer of 0.6. I take this log 4 value 0.4 divided by R. Done. So you have to find log. So if you find anti-log of this, anti-log, I also did a video for anti-log value, students. Anti-log I did 0.4 by R. Easy, easy. So when I get the anti-log of 0.7, as I did a video, log without log table, so I get an answer around 5.082, which is equal to 0.4 by R. I'm getting it outside. R is equal to cross multiply 0.4 by 5. So you are now finding the R value, which around you'll be getting an answer of 0.79. So the means initial concentration, initial rate was 0.7. So basically not initial rate. They asked me to find at T is equal to 100 also. Now initial rate, what happens? How much will it be when it will become equal this set? Correct. So now what am I going to do? I'm going to do the calculate the initial rate of the reaction when the particular concentration becomes equal to this. Check. So initial rate is T is equal to 0 and T is equal to 0. R concentration 0 minutes. R concentration is 0.4400 mole liter. K value is 1.626 into 10 raised to the power of minus 2 minute inverse. So initial rate is what? Initial rate is Initial rate is K into R. How much is K? 1.626 into 10 raised power of minus 2 minute inverse into R. R value is 0.400 mole liter inverse. So I finally get initial rate value as 6.504 into 10 raised power of minus 3 mole per liter per minute. This is your answer for the initial rate. Easy. So basically they have asked me a question. Understand the question once again. Rate constant they asked me, initial rate of the reaction, and after how many minutes it is going to become equal to 0.325 initially. So I've calculated the answer. Check it please. Next question. Let us see one more question. Very important question. The data given below is for the reaction. Yes. Calculate the order. Okay, one second, friends. Basically, here one important thing: order of the reaction, rate constant reaction, rate law of the reaction. So, shall I give you this for the homework? Can I? Shall I give you? Try this for the homework, students. Try and please mention your comments, mention your answer, mention your answer in comment section. So please check comment section. Please try to tell me the answer. Okay, I'll be waiting. The best answer will be pinned. Yes, students, remember the best answer will be pinned. In the comment section. Okay, so check. So I request all of you to please subscribe to the channel, like the video, share the video, and comment in the video. Yes, so remember, I'll be coming back with revision series 3. Okay, revision series 3 coming up very soon. Bye bye, students. Bye bye. Thank you so much. What should you do? Please share the video. Thank you. Thank you for watching.